CPTM members, SMAP partners, gather today specifically around their annual general meeting, which will be in the afternoon between 2 and 3 London time. As usual, the CPTM at large, which is what it means, CPTM members, they usually gather not only in observing the formal governance of the CPTM Limited since 1995, but also to gather ideas and new clarifications about the kind of activities, concepts, down-to-earth problems that arise in our own usual activities. And in the last 23 years, in 1995, we are gathering all the CPTM members at the CPTM Partners Hub in London, which was set up to support CPTM Limited, as a company limited by guarantee, which functioned since 1995 on 13th of June 1995, when it was set up, after which Commonwealth Heads of Government launched it in New Zealand. CPTM Limited is the formal face of CPTM at large and the SMAP partnership movement. The SMAP partners and the networks started in 1992, 1984 probably, to be more precise. So today we have a particular focus which, in addition to the formal update of the CPTM Limited governance, we are probably reckoning that there is a turning point in the life of CPTM SMAP partners. And that is to do with the data. If in 1984 we were excited about science for technology, for development, as different from science and technology and development, and found ways and means to bring evidence that there is science for technology, for and ways and means of achieving that, which is networks, and particularly within the Commonwealth family. By 1995, there was a partnership family. By 2018, there is an inclusive partnership, Commonwealth and beyond family. But not only that, there is a completely new focus, which is to do with leveraging value for knowledge and data through SMAP partnership. So today, from 11 or so in London, up to 12:30, or it could be going up to 5 to 2 if we want, usually do. We have an open house. The open house will focus on the the essence of what is data. We brought evidence in the last 5. When we say we, the brought evidence that is important, that the data makes a difference. But the data itself is not something that you can physically see. But we were able, through the governors of central banks, through the national statistics, through the actually professionals and chief executive of Bureau of Standards, to be able to get the nearest we can to understand that there is a value, there is evidence. For that reason, a whole program for the next 2 years, the most intensive program, has been put together And Commonwealth heads of government who met this year in London in April, they've been alerted to it. And this morning, we're trying to get to the essence of what is this leveraging value of knowledge and data through smart partnership for the next 2 years, implemented through networks. At 2 o'clock, we'll have the CPTM limited formal annual general meeting. And at 3 o'clock, we will have now how do we think in the new format? Smart partnership will be able to capture and to continue and to develop new modes of operation for leveraging value of data, not only in the Commonwealth, but beyond. So we have 3 parts. First, the essence of the current preoccupation and of the smart partnership movement activities. Second, the formal 23rd annual general meeting of members. And thirdly, how to go about to carry forward the smart partnership ethos and the limitless opportunity in the value of data. So then we have here at the hub a few of our members, a sample, like Andrew Tausig, who is a smart partner since 1990. 2001. I thought you were for much longer. Middle age in smart partnership movement. But Dr. Andrew Tausig, whose profile you will see, he's also a director alongside other directors later. He will join me to moderate, and we will try to moderate the discussion around what is data and who told you so that that is data, with Professor David Hand. And we are very grateful to David that for the last so many years we featured him in our own network, and today able to guide us on how might we define data at this point of time. But probably by next year there will be more to say. So, please.
Thank you, Mihaela. I just didn't want to delay us hearing from David Hand, but I just had a few thoughts about how one might place data in the context of the various things which the smart partnership movement does, which, as all of you here know, many of you better than me, and including Tom de Gregory, who is listening in Texas, it's this wonderful balance of theory and experience, of thinking about the past and drawing wisdom from it, but also looking towards the future. And it's something quite special, which is very hard to define, but we know it is there. I just wanted to mention 3 or 4, the 3 initiatives really, which precede the emphasis on data, but I don't like the word precede because actually they're very much combined with that. But the 3 things which, in the interests of socio-economic transformation and using smart methods, smart partnership methods, have been focused on over the years are first, an emphasis on quality and standards, both for the purposes of people in countries around the world, especially Africa and Asia, the Caribbean, standards which, and this is a point that Tom de Gregory has himself often made, enable countries to compete in world markets. And we have this phrase, cooperating to compete, and thus leveraging value for their economies. The second is financial inclusion, which is obviously a way of giving more and more people a stake in the future of their country and enable them to communicate with each other. And the third is the intensive and sensible application of science policy so as to leverage the value of a nation's resources and the value of its inventiveness, which, as Dr. Omar has often said, is leveraging a combination of material capital and human capital And as we move to this key subject, this key fourth tool of data, I like to think that this is a very smart tool to use because it is one which is quintessentially following smart partnership principles of informing, sharing, and giving the capacity to initiate and instruct by what it reveals. But I won't say more than that because I don't want to take the gloss off the icing off the cake of what Professor Hand is going to say to us. So I'll leave it there, but that was just an attempt to put data in the context of other things that the movement has done over 25, 30 years, really.
In fact, Andrew, if I may kind of add that Len is not online, but Tom knows about it, that since 1984 up to about 1992, we were very preoccupied with application of expert systems. Now, that was so long time ago, and our group was preoccupied with things which only probably today in machine learning and artificial intelligence are really widely spread and people are trying to understand. But we were preoccupied in the Caribbean region together with New Zealand, UK, and ISPRA, the Joint Research Center. We're preoccupied in trying to apply expert systems to research and development evaluation in management context, in real time. So that's something probably, David, that you may want to pick up as evidence of not how smart we were, because that doesn't bring us any brownie points, but is how the use of data and the focus on data was right from the beginning when we started to be visible as a group. So I suppose David will try to give us a framework and then we will be able to come in. We have here, in addition to Tom and Alan, Alan represents actually the whole group on Quality and Standards Initiative. I'm very grateful to him, former Secretary General of ISO. We have Emerging Digital Landscape, currently represented by Oliver Oram, Chainvine, a well-known company by now. We have John Blackshaw from Australia, again interfacing between quality management and GDPR lately. We have General Iksan Shurdom. Usually we call him Iksan, but I will put him on the spot later to tell us what is his background. We wouldn't dare to sit near him when you hear how many medals he has and for what. Then we have Dr. George Christodoulides, who's kind of one of the most senior respected Mediterranean, not only technologists, but probably he will tell us what it is, but he is well known in European Union. We have Mike Wright, UK, but you were with ICI before. Okay. And we have Keith Jordan, who together with Tom and myself, we are the kind of trying very hard to keep limitless opportunities to date as a living manifesto. But otherwise, Keith, you were with Rover and with the Department of Trade and Industry at the time in UK government. And we have the top senior negotiator otherwise, but from the office of the president, and congratulations to your country, having just gone through peaceful and successful elections. So Dr. Boniface from Cameroon, whose Vision 2040 is very much an example of continuity. We have an engineering background from nuclear industry. Nuclear industry, however much one thinks that is going down, probably it will continue to float while environmentalists are making efforts. So others will join us and we will let you know as they do. David, please. is all about data.
Power of data, but I'm going to balance it. I'm going to show you, I hope, how something you already know, how immensely powerful data are for revolutionizing the condition of humanity, but also point out that we have to tread carefully because, as I said, like any other powerful technology, it can be used for benefit or the opposite. So let me kick off with an observation which I made a long time ago now, over 10 years ago, that our civilization, our quality of life and so on, come from facts, information, observations, from understanding the world about us and taking actions on the basis of that understanding, essentially. You will be, you don't want me to start. You will be aware of quotes like this. This is from McKinsey about the data revolution, which was about to hit in 2011 and which we are now experiencing on the cusp of a tremendous wave of innovation, productivity and growth, all driven by, they called it big data, which was the popular term a few years ago. And you can make that sort of statement about any other aspect of human life, medicine, science, government, whatever. I think this is generally true. Actually, I do disagree a bit with this. It refers to the cusp of a tremendous wave of innovation. I don't think that's quite right, because that suggests we're going to go over the top, a peak sort of thing. But I don't think that's right. I think we are actually on the slopes of a mountain. It's going to go on increasing, and the promise is going to go on increasing. The interest in these sorts of ideas is illustrated by this Google Trends search from 2004 to 2018, which shows how people have suddenly become very interested in these sorts of things. This is in data science. But the truth, of course, is that these things aren't new. There's a huge amount of media hype associated with these things. The media catch on, they latch on to certain phrases. And if you actually look back, it used to be that these things used to be called statistics, then they were called data analytics, business intelligence, business analytics, big data, data science. I don't know what the next a phrase is going to be, but really they're basically more or less the same, slight differences perhaps. But I think now the potential has gone out into the sort of public domain, if you like. People have recognized the potential. You might legitimately ask why, what's happened now? And I think there are four things that have led to the sudden rise in interest, and they're things that you're familiar with. It's the electronic revolution, basically. Tremendous growth in data storage capacity, faster and faster computers that you can do things now in a split second, which would have taken months before. Automatic data capture, I think, is crucial. I'm going to say a fair bit about that. And then new kinds or sources of data. So let me briefly look at all of these. The first one, growth in data storage capacity leading to large data sets. And you've all seen pictures like this showing time along the horizontal axis, and in this case the size of data sets which can be stored along the vertical axis on a logarithmic scale. So it looks linear, but in fact it's getting faster and faster. It's accelerating. And you've all seen numbers like this. I've just pulled a few off sort of top of my head, if you like. 2015 there were 1.5 billion Visa debit cards around the world. In the year to 2015 in the US there were 35 billion Visa debit transactions. In 2009 around the world 10,000 credit card transactions per second were made. Big numbers, large data sets which can be stored nowadays. But it's important to bear in mind these numbers don't really matter. And this is related to many of your definitions of what data is or data are from earlier. The sizes of the data sets don't matter. It's actually what they tell you, what information you can squeeze from them. The number of pixels in a photograph isn't important. It's what the pixels are showing you, the shapes that they're showing you. So the second thing was faster computers, another of these plots. In fact, that's also on a logarithmic axis, so that one is accelerating faster and faster, the speed, and you'll be familiar with Moore's law, the number of transistors.
Actually, is Moses online? Moses? I understood he's online.
Okay.
You're talking about faster computers.
Ah, yes, yeah, he's an expert. Yeah, we can get, yeah.
Right.
So Moore's law describing how the number of transistors which can be squeezed onto a chip increases very rapidly over time and so on. And then the third thing was automatic data capture, which I think is an underplayed and under-recognised aspect of what's going on now. It's manifest in real-time things, in streaming data. So of course, autonomous vehicles, driverless cars, intensive care units, and so on. I'm going to say a lot about secondary data because I think this is important, but automatic data capture occurs, for instance, in supermarkets where the details of the transactions are occurred to process the transaction, but then it's automatically stored. And of course, there's a wide variety of different kinds of data. It's not simple numerical tables. It might be signals. It might be images. It might be all sorts of things now. And that leads me on to the new kinds and new sources of data. Administrative data, I think, they've become very important, especially in national statistical institutes. Traditional mode of capturing data in national statistical institutes in the past was surveys. Increasingly nowadays, they are shifting towards the use of data which have been collected for some other purpose. For instance, tax records or education records, and processing those. So their data, administrative data, are data which are captured during the course of some operation and which are then retained in a database. I mentioned supermarkets a moment ago. The actual transaction is so that you can work out the total price of the goods in a basket and work out how much you should charge someone. But once that transaction has been made, now with electronic technology, it's squirted over the information, the data is squirted over to a database where it can be retained and subsequently analysed to improve the supermarket operation, understand customer behaviour better. The advantage of, the supposed advantage of these kinds of data are, first, they're cheap because they're already being collected for some other reason. So all you've got to do is store it in the computer. It doesn't cost you anything in principle. And in a similar sort of vein, for the similar reason, it's effortless. The only effort is actually storing it in the computer. It's already being, the effort of measuring it, if you like, is already being made. And of course it's accurate. If your supermarket didn't get the numbers right, it would soon go out of business. Those are the claimed advantages, and you know, they are real advantages of administrative data. But as we'll see in a moment, they all come with qualifications. We have to tread carefully. I'm not going to go through this. This is something which I think you'll all be familiar with. It started with the 3 V's of big data: volume, variety, and velocity. How many records there were, how many different variables there were recorded, bits of information about each person, for instance, and how rapidly the information comes in. But then people added veracity and value, and no doubt they'll continue adding V's whenever they can have time to go through the dictionary and think of an appropriate one. So I thought I'd give a few examples to sort of illustrate these ideas, although I think you will be familiar with them, of some of these new kinds of data sources. I mentioned scanner data from supermarkets and credit card data. Also, of course, monitoring transport flows, footfall data, shipping. I'm going to come to shipping in a moment. I've got a nice example. I was thinking there of road transport and movement of people around cities and things like that. But footfall data, monitoring people, how they go between shops in a mall or something like that, how many people use particular shops and so on. The red ones I'm going to show you little images of just to illustrate ship movement data, oil storage data, crop yield data, and telecoms data. So this is a little, if you go to this website, it's quite entertaining. So if you've got a spare moment, you might like to do that. It shows you details of all the ships around the world, where they're going, when they're going to be there, what they're carrying, and so on. So this particular image is one I pulled up. I pulled it up on 28th of July of this year at 10:34, and it tells you that the name of the ship, the Heron Hunter. Its destination is Macass, and it was expected to arrive on the 1st of August at 3:30 in the morning. And you can do that for any ship in the world. This image also shows you why the English Channel is so dangerous with all those ships going up and down. It's very sort of busy. It was supposed to arrive at Macass at 3:30 in the morning on August the 1st, and you could check. Macass. Yeah, I don't. Yeah. And it's quite entertaining that you can do that for any ship in the world. just on that website. So readily available data, extraordinary data. Oil tank data, this is a satellite photograph, 3 satellite photographs of the same oil tank with different levels of oil in it, which again you can get from satellites. And of course you can, from these images with a little bit of school trigonometry, you can work out how much oil reserves there are in these tanks. Crop yield data, a standard use now of satellite data. Yes, I've said here, satellite data have repeatedly been shown to provide information that by themselves or in combination with other data can accurately measure crop yields. That in combination, I'm not going to talk about, but it is very important. It's talking about data linkage or merging data. The potential from merging data of different sources is immense, because different data sources will complement each other or supplement each other, or you can use different sources to triangulate data to overcome data quality issues, which I'm going to talk about in a second, or missing data or things like that. So merging data sets, using them in combination, is a very powerful tool. And so it goes on. You can tell if there are going to be if droughts are going to impact yields and so on. And then finally here, my final example is telecoms data. 94% of adults in the UK have mobile phones, and these give you all sorts of information: location, population flows, so how people are moving around the country, for instance, so that you can organise more efficient transport networks and so on, population densities at various times in the day, tourism data, all sorts of things. The point here is 94% people in the UK have mobile phones, but in many other countries where the infrastructure, perhaps the other aspects of the infrastructure isn't so developed, people have mobile phones. So these are a very rich source of data, of all sorts of different kinds of data. It also has the advantage that it's pretty homogeneous sort of data. The data which comes from mobile phones is all of the same kind. So it's relatively easy to analyse. It's not all sorts of different kinds of images and signals and so on, which you've first got to transform into some sort of data that you can process. There are 3 fundamental disciplines underlying data science. We talked about definitions of data. We didn't talk about definitions of data science, which is a whole new ball game. But there are 3 fundamental disciplines: statistics, which is the most important one; computer science, which is the second most important, which is absolutely vital, of course, for actually manipulating, juggling, sorting, searching, and so on through the data; and mathematics. So statistics is used for estimation, inference, prediction, those sorts of things, finding structures in data, testing to see if things are real or chance. Computer science, I just said, sorting, merging, listing. The facility to cope with huge data sets, increasingly important in the context that we're talking about. And then mathematics, of course, which underpins both of those 2 disciplines and is concerned with optimizing, understanding high-dimensional problems and so on. 3 fundamental disciplines which have come together, which basically form data science. I've got a couple of examples which you may be familiar with. The first one is a standard example of the power of data, where again the data were automatically collected. You don't have to make a huge effort to capture them. The MIT Billion Prices project. You'll all be aware of how inflation indices, price indices, are normally calculated, or have in the past traditionally been calculated. And the way that's done is that you send the National Statistical Institute send people out to look in shops and actually write down the prices of tens of thousands of different goods which are bought and sold, and that information, those data, are then collated to give an index of how prices are changing over the course of time. Clearly very, very expensive and slow, time-consuming operation. This group from MIT said, well, an alternative way of collecting the information now would be to just scrape prices from the webs, from vendors, from retailers on the webs, and they did that. A lot of prices. They called it the Billion Prices project. They did this for a lot of countries. For instance, they did it for several South American countries, and most of those South American countries, their condensation of the data from the web scrape prices pretty well matched the inflation indices as calculated by the National Statistical Institutes of those countries. For Argentina, it was different, and this graph shows you the the lower line is the price index, the CPI, as calculated by the government, or as claimed by the government. The blue line shows you the price index that the MIT Billion Prices project calculated, which was much, much higher.
When was that?
It was about 10 years ago now, I think. Yeah, yeah. I can send you, I've got a website, but I can give you references. Yeah. Eventually, the Argentinian government had to concede that this was correct. But there are issues here, and this is what I'm going to come back to into the last part of the talk. The MIT Billion Prices project, in one of the papers, they say we focus almost exclusively on large multi-channel retailers and tend to ignore online-only retailers like Amazon. And that's interesting because it means they're ignoring part of the data. Now, when you bear in mind that in the UK, 17% of retail transactions are now made online. In the US, it's 10%, and those numbers will increase rapidly over the course of time. They're probably already out of date, even as I state them. This sort of thing of only looking at some of the data could be a little bit misleading. My second project is one that I was involved in. It was an anti-money laundering project. A major investment bank asked me to, well, I was carrying it out, hired me as a consultant to do it. And this particular thing I'm going to look at is something called the Benford distribution, a particular statistical distribution that you may have come across. It's quite entertaining. Again, you might want to look it up just for fun. It's the distribution of the most significant digit in a set of numbers, in a natural set of numbers. Most significant digit, the first number. And there's a theoretical reason which says that in many natural collections of numbers, you would expect, this seems counterintuitive if you haven't met it before, you would expect the first digit to be a 1 30% of the time. You would expect the first digit to be a 2 just over half of that, and it goes down to the first digit being a 9 least often. That seems counterintuitive because you might have expected them to be equal, but it turns out that that's the theoretical distribution is that, as I say, with the first one most common. And in fact, I've got an illustration of how this actually does conform to nature, as it were, because the red bar chart here is Benford's law, that theoretical distribution. The blue chart here is the first digit of Dow Jones Industrial Average daily returns over the course of 4 years. And you can see it's almost perfect match. So although this may seem counterintuitive, it's true. It works. You can apply this in, well, I applied it in anti-money laundering. So we looked at the transactions of one user working with this investment bank and looked at the first digits, the most significant digits of all their transactions. The black bar chart is the expected frequency you got, the one you just saw from the Benford distribution. The orange chart is what we actually found. They clearly differ. Now, this doesn't mean that this particular customer was fraudulent, was perpetrating money laundering, but it might raise suspicions. You might want to go and check out exactly what's going on. I can explain why you'd get that sort of pattern if they were perpetrating money laundering, but that doesn't necessarily mean that they were. There may be perfectly good reasons for it, but it might be worth checking out. Okay, so I've really told you now how great big data are, how great data science, the promise of data for improving the human condition. But now I want to say a few slides about cautionary notes to try to strike some balance. Just rushing ahead blindly, well, one trips over. So let me come back to administrative data, which I said had all sorts of advantage. It was cheap, fast, and accurate, for instance. You have to remember that they are, by definition, secondary data. They were originally collected for some other purpose, to run the supermarket or the credit card operation or the patient monitoring or whatever. But now they're being put into the database and used for something else, which necessarily means the analysis is also secondary. You're not collecting them to answer your specific questions. That means they may not be ideal to answer the question you want to answer. They may not be perfectly matched. When you carry out a survey, you actually say, look, I want to know the answer to this question, and you ask people that question. Administrative data, well, the primary thing is to use it for the operation, so it may not be ideally matched to the question you want to answer. issues of consent may arise. I'm going to mention the GDPR in a moment, but you're taking the data and then you're repurposing it. You're using it for something else. And of course, if the data come from an operation, if the way the data are collected or the reasons for collecting it are changed, that will change the data. And you may not know further down the line that that's happening. There are all sorts of quality issues. They're not issues of non-response or whatever that you get with surveys. There are other quality issues. And likewise, there are selection distortions. So, for instance, I might be processing credit card data to try to make some statement about the UK population, for instance. But there are different credit card operators, and people will choose to go with different operators and use their credit cards in different ways. You may get selection distortion depending upon the data set you're using and the population to which you want to jump. So the point about all of this is really that I started by saying a few slides ago, administrative data were great, cheap, fast, accurate. It's not as simple as that. We have to keep our brains in the loop. We have to keep thinking. Data quality. I have many examples of problems which have arisen from data quality, but I thought rather than giving you many examples, I'll give you a few quotes. This is Klaus Moser, former national statistician, head of the Government Statistical Service in the UK. Any figure that looks interesting is probably wrong. You should be suspicious. Kind of disheartening, really. William Kruskal, writing in 1981, I like this one. A reasonably perceptive person can sit down with almost any big data set and find strange-looking numbers in less than an hour. He gives examples of sort of several hundred 14-year-old American boys who appear to have been divorced and widowed before they were 14 from census data in America. Probably something wrong with that. Another one, most big data that have perceived popular attention aren't the output of instruments designed to produce valid and reliable data amenable for scientific analysis. So again, one should be cautious. Another one, so I do quite a lot of work with the insurance profession, actuaries. The majority of insurers around the world are failing to ensure that the data that feeds their AI systems are accurate, potentially undermining their business decisions. The actuarial profession is interesting because they've been a bit slow to catch on to the big data revolution. Interesting because in some sense they were the original big data people, going back to the 17th century. They were collecting data on death rates and things like that. And first insurance company basing premiums on the calculations was set up in the 17th century. And yet they've been slow more recently over the last few decades to keep up with this data revolution. But they're catching up now. They're changing it. Why is it? That's an interesting question. I have to think about that. This is an interesting one about data quality. In industries where regulations govern relationships or trade, especially in finance, maintaining good quality data can be the difference between compliance and millions of dollars in fines. And you will know that the GDPR allows fines of up to 4% of total global turnover, so it can be expensive. Selection bias, another quality issue. Crime maps. You're all familiar with crime maps, I suspect. Originally developed in Chicago. They are maps you can find on the web for basically any location now, which will tell you about crimes which have been committed locally, so that you can decide whether a particular street is safe to walk down or not. So jolly useful. The police create these maps. I have a map of such a thing for London, which shows that in the area of Imperial College in London, there's not very many crimes are committed. And this makes perfect sense, because if you go over to Knightsbridge in Kensington, you find that the crime rate goes up. And that makes perfectly good sense, because if you were going to steal someone's purse or handbag, you wouldn't do it at Imperial College where there's students with no money. You'd go over to Knightsbridge or This looks great, really useful. You can see what areas to avoid and so on. Except Direct Line Insurance carried out a survey, and they found that more than 5 million people haven't reported crimes for fear of deterring home buyers or renters. and a quarter of people wouldn't report a crime, they say, for similar sorts of reasons. So the data are becoming distorted by the virtue of their very existence, which makes them perhaps less useful, even useless, for their original purpose. So selection sorts of distortions. Oh, another example of selection bias, Hurricane Sandy. So these are all examples of data quality issues. Hurricane Sandy was, I think, the most expensive hurricane to hit the east coast of America at this time. And it was a massive storm, but it was accompanied by a Twitter storm, apparently showing you the huge benefits of modern social media technology. 20 million tweets were sent out when the storm hit, showing you what was happening, where it was happening. Maybe I've said that. Okay, showing you what was happening, where it was happening in real time. But if you looked at where those tweets came from, most came from Manhattan, few came from these places, and of course it turns out that these places were the most severely affected. Now it's pretty obvious why most tweets are coming from Manhattan. Most people are there, even though it wasn't hit as badly. And you could imagine a particular place being completely wiped out by the hurricane. You wouldn't get any tweets from there. Everybody had been killed. So there's a selection bias going on. You have to look very carefully at the data, not take it at face value. You're getting a distorted impression of where the damage occurred. I want to say a little bit about database models. There are fundamentally two different kinds of models. One is theory-based models based on some underlying theory, like physics theory or something like that, even prospect theory in psychology. The others are based on simple observations of relationships in data. It is that kind which has really driven the revolution that we're experiencing in the value of data. But there's a fundamental problem with those sorts of models, which they are basically rather fragile. So here's a little example, again, a little example from my own work. I used to do a lot of work with the retail banking sector, credit cards, mortgages, bank loans, car finance, and so on. So this is a plot on the horizontal axis from January 93 to January 97, and it's about loans. And on the vertical axis, the black curve shows you the proportion each week of customers who repaid their loans by direct debit. You can see it's pretty irregular. The red curve is a smooth put through that. Now, what I'm going to ask you is to project that into the future. What do you think will happen? I think if you just took the average and projected that, you wouldn't be far, that would be a reasonable thing to sort of do. So let's see what actually happened. But before I do that, remember, database models are based on looking at past historical retrospective data and looking at the relationships there and saying, this is what the data appear to show. And what I'm doing here is exactly that. I'm going to put an average through there, say I think this is what the data appear to show, and I'm going to project that into the future. And this is what actually happened. At that point, and obviously I chose that point to illustrate, at that point, people started behaving very differently. I'm not going to go into why they did now. It's an interesting story. It has implications for data collection and so on. But the point is, this model, your average put through that, based on retrospective data, is fundamentally fragile. It's vulnerable to changes in the world, changes in economic conditions, changes in the way people behave. Another example of potential problems, which we have to be alert for, is the danger of excessive searches. This is where you've got a data set, and you look at it this way, you look at it that way, and you keep looking at it thousands and thousands of times until you find something interesting. The fact is, thinking of William Kruskall's comment, you're bound to find something if you keep looking for long enough. And there's this wonderful website, Spurious Correlations. If you haven't seen it, it really is, if you want to laugh, really is worth looking at. What they do is they take a time series of data and then they trawl through the web to find other time series which are highly correlated with it. And here's just one example. These are the two time series. The black one is murders by steam, hot vapors and hot objects over time. The red one is the age of Miss America over time, and they have a very high correlation. What do you think's going on? How can one cause it? Clearly, they're unrelated, in fact, but they have a very high correlation. And if you look through any data set enough times, you look through a big enough data set, you will be able to find apparent structures which are meaningless. actually, I've referred to this before, but answering the wrong question is, again, absolutely critical. Crime rates in the UK are measured in two ways. One is the Crime Survey of England and Wales, and the other is police recorded crime. One's a survey, other one looks at administrative data. And between 1997 and 2003, this is what happened. The Crime Survey for England and Wales rate went down, crime rate reducing, but if you looked at the police recorded crime figures, it seems to be increasing. Now, why is this? Some contradiction? Are the statisticians making mistakes or whatever? The answer is, of course, that one's a survey, one's based on administrative data. They use different definitions of what a crime is. I've put them here to illustrate. The Crime Survey for England and Wales doesn't include group residences, like student halls of residence and so on. It doesn't include crimes against commercial bodies, for instance. It's victim-based. It's a survey. People are going out and saying, have you experienced a crime? You will spot that not many murder victims put their hands up and say, yes, I was murdered. So it doesn't include those. Police recorded crime, however, is based on what goes into the police records. So it's only if they match certain definitions of what a crime is. It does include murder, for instance. It does include residents of institutions, does include tourists and so on. So different definitions you would expect. You wouldn't be at all surprised if they behave differently, these two time series. Having said that, you can guess which ones the media focus on when they want to tell a story. You will have heard this expression, data are the new oil. The point about this is that oil drove the Industrial Revolution. Oil created, in some sense, our current civilization. And people see the potential for data as being just as great. I would like to make a few comments about this. The first is that, and this is crucial, and it follows from my comments about data quality. In order for data to be useful for squeezing information, for basing predictions on and so on, it needs to be processed and refined. And there are also other issues. Data per se are not useful. It depends what question you want to answer. It depends what you want to do with the data. Data also, unlike oil, you can sell it and you can keep it. You can sell it multiple times. You can't really do that with oil. Unless you're like that man Lustig who sold the Eiffel Tower twice. You can duplicate it an unlimited number of times. You can't do that with any physical commodity like oil. You can use it for multiple different purposes and so on. There are also all of these issues of privacy and confidentiality which don't have any parallels with oil. So yeah, data are the new oil, but here's a final little example, I think, of data quality. An IBM report not long ago said poor data quality costs the US economy around $3 trillion a year. That's a large number, a very large number. And you might ask how they arrived at that. Does it include the cost of putting in systems to stop poor data quality getting through? Does it include the cost of things going wrong because you've got poor quality, the cost of improving the data quality and so on? Depends how you define it, how you get that number. But US GDP is about $20 trillion a year. Well, this seems to be a hell of a big number. So you might ask yourselves, is that in fact an example of bad data, of poor quality data? I like to summarize this cautionary note by saying that if the numbers can speak for themselves, as Chris Anderson famously once said, he said you don't need models, you just need the data because the numbers speak for themselves. I like to say if the numbers can speak for themselves, they can also lie for themselves. So one should always approach things with caution. There are other issues I haven't talked about. Data ethics has become a very hot topic. A number of different organisations have been set up within the UK, the ones I know about, to do with it. The Department for Culture has set one up, the Nuffield Foundation has set one up, and so on. The GDPR is slowly working its way into society as people come to terms with what it means and try to interpret it, which of course gives a right of access to and control of personal data. I think independent oversight bodies are absolutely critical here, so that you know that the numbers you're getting, the data you're getting, what you're extracting from the data are actual valid representations of what they're supposed to be, monitoring or measuring. And then there's a skills gap. This is important. You know, those graphs that I put up at the beginning, those exponentially increasing graphs, more and more people, we're going to need more and more people to analyze the data and process it. Number of students, this is just from the US, from the American statistician, number of students studying these things is going up, but I think the demand is going up even faster. And of course, qualified students with experience who've done more than just graduated but actually got some experience, there's always a lag. So I think biostatistics is statistics concerned with biological organisms, ecology, medicine, health, and so on. Yeah, well, yeah, and anything but physics or chemistry, so other things. Yeah. So to wind up, conclusions. The last half of this talk has been maybe, I hope you won't interpret it, but possibly pessimistic. But it's really been saying you should exercise caution. Don't expect miracles to happen overnight. There are pitfalls. Nevertheless, there is vast potential. But remember that data alone, just because you've got a big data set, doesn't matter. Size doesn't matter. It's what you do with it that counts. Oh, that's what I've said there. It's information content that counts. Data quality is critical. I've kept stressing that. Then there's the skills gap. I think a good sort of take-home message from this is that massive data sets by themselves aren't any good. You should always start with what you want to know, with the question. I think that's the critical thing. I had experience of at a conference of a banker coming up and telling me that they'd spent a lot of money and some years pulling all their data together into a giant warehouse. Then they'd brought in a consultant and said, look, you've got 3 months, find something valuable in the data. And he was very disappointed when this guy didn't find anything valuable in the data. I think that was pretty silly. He should have said, look, were you interested in knowing this or this or this? And found out if the guy could answer that question. Just going and saying, find something interesting is not useful. You should start with what you want to know. And my final observation comes back to this point that nobody actually wants data. What they really want are answers to questions, which is why you have to start with the questions. So, stopping there. Thank you very much. Yeah, that's the question. I suppose maybe it's my personality type. When I see people rushing ahead and saying, look, this is wonderful, I'm naturally cautious. It might be that. But having said that, there are a number of illustrations, many of which you will be familiar with, I'm sure, of people who have rushed ahead without thinking carefully about the data and have made mistakes. The Google flu trends case is an example. But I think it's also true that statisticians are intrinsically cautious. Statisticians tend to be aware that their models, their analyses are necessarily based on certain assumptions. And if those assumptions to do with data quality perhaps, assumptions to do with distributions, if those assumptions aren't met, the conclusions may not be accurate. Statisticians are aware of those things, but people in other disciplines also concerned with data may not be so aware of them. And I'm very much aware, for instance, in the early days of neural networks and so on, people from the computer science sort of technologies rushed ahead and did quite remarkable things with early neural networks and related ideas, statisticians were behind them on this. They were lagging behind. Which means, of course, when the statisticians catch up, they can say, yes, your methods are doing well because of this. They can develop the theory. And it also means that the computer scientists rushing ahead are risking falling flat on their faces because of the sorts of issues that I've raised. I mean, you know, computer scientists have an acronym, garbage in, garbage out, which I think summarizes the need to be cautious.
So in other words, as recently the new Nobel Prize, the economist Paul Romer was saying, there is a conditional optimism, not a complacent optimism, which is what one kind of,
Thank you very much. You reinforced something I learned many years ago. The United States Navy runs a course called the International Management of Defense Resources. And the main thing you conclude from this course, it's a postgraduate course, or they call the flag course, is beware of statisticians and statistics, especially in modeling, because you're absolutely right. It depends what they base it on. And this becomes a major problem with defense contracts, etc. Thank you.
I think maybe that's beware of statisticians and statistics, but it should be coupled with, but you need them if you're going to extract information from the data.
It's been said in the description.
Liars,
Liars,
statistics.
great liars,
Yeah.
and statisticians. Right.
When Disraeli said there were lies, damned lies, and statistics, people usually interpret that in one way, but another way of interpreting it is that he was contrasting lies and damned lies with statistics. So there are lies and damned lies. On the other hand, there's statistics, which is actually squeezing something from information.
and the damn lies are the equivalent to fake news.
Ah,
But
that's a good, yeah, that's,
we'll bring up later.
Yeah, thank you very much, David. I'm very much impressed with the presentation.
thank you.
And thank you, Mihaela, for thinking that this presentation should be made. Again, as I say, this is going to help my country very much. I have traveled all the way to come here in order to learn so that my country can benefit from this. And I think it can be done. So it's not a question I'm asking, I'm just proposing that I have learned a lot. I'm going to send this to the technical ministry, the Ministry of Economy and all of those planning and so on. Yes, not even for the whole country. And so I'm just suggesting that your presentation can be made and presented in the form of a paper that was presented for the 23rd session. So that when I get there, I'll submit it to my chief, my boss, and say, this is a document that was presented at the CPTM on such and such a day with this cover. Yes, well, to the economy. So I just want that it should have this label that presented today. And I suggested very much so that when I go home, they will transmit it to the ministries, the technical ministries concerned for the application. And just to end up, what the others have just said, there's a book I'm writing, Mihaela, and one of the books, Becoming a Total Quality Negotiator. And one of the chapters has to do with logic and negotiation. And in logic and negotiation, there are a lot of fallacies that people commit when they negotiate with you. Especially what they call the fallacy of ad numerum. That's quantitative. People want to tell, that one of the ways people tell lies and default information is the use of statistics. Argumentum ad numerum. They quote statistics and this and this and this, but sometimes they are not real. So I'm very happy. So we are looking forward for this to get this paper. If I can get you before leaving tomorrow.
No, for the country, for Cameroon. So I don't
ministry, consult the prime minister, everybody to implement what has been said here.
Yeah, Mike, right. Yeah, I'd like to pick up a couple of points that David made that I think are well worth repeating. There's a very amusing story in the paper this morning about the city of Shanghai, where they have a data streaming by facial recognition system for naming and shaming people who walk across red traffic lights. Well, they did this, and it turned out that it was the president of a big important air conditioning company had a face suddenly appeared in the middle of Shanghai as a terrible jaywalker. It then turned out that the reason for this was that a bus with her photograph on had gone past the traffic lights. I mean, and this thing gone straight through without any kind of further processing or whatever. For example, well, the business case issue is so important. Another piece in there about banking, that there's a young guy, couple of years, they've set up a database bank, online banking, and this thing has boomed to £1 billion turnover in a couple of years. And he said, well, I think the big banks are in trouble. And if you look at the data say that costs the big banks to service a pretty average bank account £150 a year. It costs us, with an online bank, £12 a year. And they're at the moment targeting cost reductions of 20%. He said, no contest, they should be looking at 90% cost reduction. So the business case is so important. Don't jump into this stuff without knowing where you're trying to get to.
I think one of the dangers that I didn't talk about of machine learning and artificial intelligence systems at the moment, which, although they've come a very long way since the sort of 1980s, are still pretty rudimentary. I think one of the big dangers is that they will make mistakes of a different kind that we would never have thought of and don't recognise, so we don't know why, which pixels they're looking at in an image to make their recognition and so on. So I think that's the particular danger. They'll make mistakes of a kind we haven't thought of.
Keith Jordan. David, I'd like to follow on really by saying there were 2 or 3 key points that hit home to me. The first was the issue for a business case, but not just a business case. The reason why, when approached by someone who tells you, if you don't really understand big data and their ability to help you, you really need to be very careful. You need to understand what is the reason why you want to use big data and the algorithms that go with it. So that was the first thing that struck home very hard. Secondly, I was interested in the comment about actuaries. I think the reason, and I speak as a father of a chief actuary, I think it is because the people who are in the actuarial profession now, and we know they used to say an actuary is someone for whom accounting is too exciting. I think it's a generational thing. I think they're very comfortable with algorithms, they're very comfortable with data, they're very comfortable with using IT. And I think it comes naturally to them. And the third thing I was going to say is that throughout this, you have not erred on the side of, but been very clear, as you said in your preface, to balance it. And I think that's a big issue for us in CPTM. You used in one of your previous papers, which I had the opportunity to read, the word provenance. And one of the things about CPTM is we have an inherent provenance, because people believe when we say things, we have a reason and an evidence to say it. And I think provenance is one of the biggest issues here. And I'm just holding up a book that I'm reading. I guess you've probably all read. 21 Lessons for the 21st Century. And it really does sit alongside your presentation today. My fear is that the algorithms I talked about earlier that are being used by people promulgating and recommending big data, they can be self-refining. They draw more data in from different areas. And if you're looking at that reflection of human behavior, I think there's a possibility that we humans can be lazy and we begin to react as to the data coming towards us as being evidence which we instinctively believe.
Tom, are you online? Tom, are they muted? Could we make sure that? Because I don't think they're allowed to. They have to go through. Because Moses has something to say.
Would you like Moses to go first?
Just before you go, you didn't mention the word algorithm vis-à-vis, but he brought it in.
I think that's
Algorithm
yeah.
data.
That should have done. Statisticians tend to think in terms of models, and I'd be surprised if I didn't mention the word model. Computer scientists tend to think in terms of algorithms. Algorithms are, you take a data set and you process it through an algorithm. A model tries to summarize data in some way. So these sorts of things are complementary. But of course, both are needed, both are necessary. Yeah.
And the mathematicians do talk about.
I suppose they do both. Yes. Yeah.
Okay.
Sorry, yeah. Hi, David. So you ended your speech there with, we don't want more data, we want answers. And I think that's quite right. I think I see a lot of public bodies, corporate entities, they actually don't want more technology, they want solutions. And this is the key here. What is the solution and what is your process about bringing me these solutions? So I think when we speak about provenance and origins, it's the process of which we come about the provenance and origins of a certain good or information we have. And I think giving concrete examples such as anti-fraud is a very good one, how we can use data. But right from the beginning, the process has to be established. I just see the technology as an enabler of better process, perhaps more streamlined process these days. So entities and corporates face two major challenges. One is the lack of data, and the second is a problem of actually having lower margins and more pressure to make more gains. Now this leads to sometimes us skipping a certain process, or indeed tweaking a process, not maybe manipulating the data, but tweaking a process that would in essence make that data come out as not statistically correct to some people. I think the emissions testing in Germany was a classic case of this, whereby middle management just changed a needle here or there to show a different outcome, but in fact knowing fully well that outcome wasn't really the right process that should have been followed. So provenance and origins are extremely important, and it's the way we read data and the way we access the data as well that is, I think, critical. I think
they say two things about economists: they're either completely mad or depressed. And I think that's because that's the way they choose to read their data.
I think those are all very valuable points. And I think your example of the car emissions test in Germany is a nice one, because it comes back to the lies, damn lies and statistics argument. When those sorts of frauds are perpetrated, if you like, when data are misanalyzed, the blame is often attached to the statisticians, and that seems a bit unfair, because it's not appropriate that it should be attached to the statisticians.
But can one speak about the wealth of data and what is the meaning of that? Because we're a wealth of nations and all that.
Wealth of nations.
Wealth of nations
Yeah,
equivalent to what of data, because there are data centers emerging everywhere.
Okay, one can talk about a wealth of data, meaning you have a lot of data which might be valuable for some purposes, but as we've discussed, data per se are not valuable. Depends what you want to know. So you could talk about, I suppose, a potential wealth of data. not the wealth of data like in the wealth of nations, but a potential wealth. Yeah.
Just a few words, really. John Blackshaw from Australia. While you were talking, I was thinking that people have an assumption that whatever's coming out of this data analysis, big data, is what it is that we're going to adopt going forward, in a sense, in terms of a policy decision-making process. And the thought was, is there an argument to have a secondary group this data can be, the analysis of this data can be given to verify this? Because I'm thinking more of climate change is an example of different models of data coming forward and having different outcomes. So from a policy implementation perspective, it leaves the policymakers without that fortitude and so on. So I was just wondering.
I think that is a very important point. I'm quite heavily involved with the UK Statistics Authority, which oversees the Office for National Statistics, which produces statistics about the UK society and economy, and also oversees other parts of the Government Statistical Service. But the UKSA also oversees the Office for Statistics Regulation, which takes a critical eye on the numbers which come out from the ONS, the Office for National Statistics, and said, are the data valuable, trustworthy, and so on. So I think this notion of independent oversight bodies, which look at the results coming out, which look at the data going in, and ask the question, can they be trusted, is absolutely vital. So an oversight body, and I think an independent one, so that you know that its conclusions are not going to be distorted or biased by what somebody else wants to know. So I think you're spot on. Yeah.
I'd just like to add, because the membership basically is from Africa or Asia, and not sophisticated in the same way that the first world countries are. How do you feel that they could manage this process of mining their own data?
Yeah.
And maybe using, I was thinking of using some of this higher level computer capacity to manage their data. What should they be doing to bring their data together in order to present something to a major data center for this analysis to go on basing it on the questions that they want to ask it?
Yeah.
So how should they perhaps think about channeling their data into another to get an answer to their own data issues?
Yeah, I think I suppose underlying the second half of my talk is caution, but I do think having a body monitoring the quality, checking it, going back to where the data came from to check how it was collected and so on, is going to be very important. Because there's no point in collecting data if it's of poor quality, if it can't be trusted, if the results of the analysis are therefore meaningless or useful. You're just wasting your time. So it is a fundamental criterion that the data should be reliable and of high quality. So I think having a number of layers which can enforce and ensure that is going to be absolutely critical.
I think Moses is online. Moses, are you online? Okay, I think they're muted, but they are online.
They're effectively gagged. I'm Robert Smith. One thing that concerns me is that we seem to have, as predicted, an increasing flood of data, big, whatever you want to call it. And how do we manage it? How do we ensure that it doesn't actually become a major driver in itself? We sort of should be, to me anyway, we should be using it for our own purposes and not saying, I think you said this several times, because we've got it, we ought to use it. So how do we ensure, first of all, that we keep it under control? How do we ensure that the effects of using it are for the better? how do we ensure that the benefits and detriments are distributed? How do we ensure that is not put into the hands of a small those are, yeah.
I think the answer to several of those questions comes back to the point about the business case. You start with what sort of things do we want to know? What types of questions are we trying to answer? And then you think about what data you would need to be able to answer those questions, rather than just collecting the data sort of random and then saying what can we do with this data. That's the answer to some of the questions. Your other questions related to the dangers of massive data sets about human behavior, about individual behavior falling into the hands of a small number of individuals. We all know the sort of thing that you have in mind here. I think those are real dangers, but I think the answers, in some sense, the answers to those aren't technical answers. They're legal. They're bigger societal answers. So it's our politicians and so on who have to answer those sorts of questions.
Okay. Really, I just wanted to. I'm sorry I was late. Obviously missed a lot of what you had to say. The question over GDP and the way in which we use it, and what is used to make up GDP. And clearly, the way in which the sort of internet, the way in which the web and all the associated businesses that have been created in developing it are structured, makes it very difficult to include what they do into GDP, because there's no cost structure. I mean, there's so much of it is free. We get it free, we're told, in exchange for all the data which is collected, and no doubt our exposure to all the advertisements that we see. But it is almost impossible to solve this problem. And I just wondered whether you'd sort of had any thought. I know you're not an economist, but I wondered whether you'd had thoughts on what you could use instead of straightforward price.
Absolutely. This is a very important point. In fact, I co-authored a book called The Wellbeing of Nations, which was about exactly these sorts of issues. GDP is not a great measure of economic success or progress, let alone these wider issues of sustainability, of the natural environment, of human capital, and so on. I think, I feel quite strongly that we need to move away from narrow economic definitions of progress, which, as I say, even that the GDP isn't very good at measuring, but we should move away from those narrow economic measures to broader measures of societal well-being and progress. And if we speak afterwards, I can give you the details of the book, and the answer to your question is really in that.
Just a brief comment. Mahana asked about the wealth of nations. I think it was important from what David showed. There is a significant interest now, growing very rapidly in data handling. What's different between wealthy nations and not so wealthy is generally the amount of knowledge that is disseminated all the way down to the population at large. So they can use stories, information, data much more efficiently themselves. So they're not going to be manipulated by a little crew of people who have all these magic numbers. They're going to challenge it because they're operating from a basis of knowledge. So I think the education aspect of big data and how you handle all of this stuff is what will make the wealth of nations quite different from one another.
At the school level, awareness of what the potential of data is, and the sort of the cautions, the qualifications that I've said, but also transparency. I think enabling people to see what's going on. You know, there's been a lot of talk about open data over the last decade or two, and increasingly in the UK, for example, individuals are able to access data which tell them, for instance, how public bodies are behaving. So Manchester, for instance, the Manchester local government publishes details of any purchases that are made by the local authority of above £500, which cost more than £500. Those are all available on the web. You could go and look them up. And that enables individuals, it enables the public to see what's going on and to understand why it's going on and so on, to check that things are being done for the public good.
Regarding the sharing of data and how does one go about that, or how does one actually make that process happen. And I just did a quick search here just for a good example of where the sharing of data between different nations and the wealth of data could practically stop an economic disaster or even affect thousands of lives. And if you look at the Ebola crisis of 2014 to 2016, there was an inability to share data. Now there's a platform being devised in Oxford by IDDO, and basically they want all of the West African countries to begin to share this data. But if you think about sharing this data, it's not just the old data, but it enables them to combat any future outbreaks. I think there's about 11,000 deaths, and then if you think about all of the borders that were shut down for months, the economic impact of this kind of disease, especially on porous borders, without any kind of data sharing is critical actually for the survival of some of these countries and economics. I think the devastation caused by the disease was more. The impact was huge. So I think there needs to be a balance between what happens if we don't share our data, what are the repercussions of this, and this platform is quite interesting because of the ownership of the platform must be shared between its members. And one copy of it will be kept in Oxford, I believe, here, and the other copy should be kept in West Africa. The location is still to be decided. But I think this shows actually like how the banks came together years ago to tackle fraud, because it was one true enemy to all of them. Just as this is a true enemy to the economics of sub-Saharan Africa, that it needs to be looked at in West Africa, that the actual benefits of sharing data by far outweigh any sort of accidents that could come by sharing that data. So it's the importance of sharing data and the process of sharing that data, and give a good example of why we should share data. Exactly, yeah. I mean, if you show the economic case for sharing data, and this is the same as corporates as public bodies, what they're beginning to understand is actually keeping all of our data sort of tucked up in a silo, it's not doing any good there. And actually, this is the reason why, for instance, open source technology has gained so much ground, because of many people can test and study this data, or this software, if you like, and you're validated by thousands and thousands of people. But if you keep your software locked up in the license and only 300 people are checking it every day, I think I'll trust the software that's being checked by 30,000 different developers across the world putting input into it than I would a closed off license. Yeah, I think exactly.
But just still around this metaphor of the wealth of nations, because and the wealth of data for it, and the openness, because the idea of nodes and people decentralized. One doesn't talk about decentralization as such unless you are in a centralized system, but networks of people. I mean, the networks of actually are equivalent to wealth of networks. And the wealth of networks are wealth of data. And the whole thing is probably a new wealth of nations from now on.
the education point that you made, I think, yeah.
But you haven't also mentioned, I mean, there's so many things that you probably will continue for the next 2 years or so. The issue of security of data, because this is one of the main preoccupation of the central bank governors, the in relation to the inclusivity and financial inclusivity. And only yesterday, when you say that somebody's collecting data, it could be that it's administrative data which is being collected, not necessarily for a purpose, like we all know about Facebook. So yesterday there was another revelation. Ben Hammersley sent us a tweet, Ben Hammersley, one of our group members, saying that here is again Cambridge Analytica implicated even more so in using second-hand, not only first-hand, like from Facebook, the data for other purposes. So how can one kind of liberate data or think in terms of data versus oil equivalent? How can you leverage data within a context where you have Facebook giants that are picking up administrative data, secondary data, yeah, which has been traded off with whoever?
Coming back to an earlier question, I think the answer is not a technical one. I think it's a legal one. It's to do with the structure of society, monopolies and so on. So I think it has to be dealt with at a higher sort of level, yeah. But it's critical. But your earlier point about data security, I mean, you need to know that the data, that raw data are coming from sources which can be relied on. They're collecting the data in a trustworthy sort of way. But then you also need to know that data are being stored, and you can trust people, the organizations, to look after it, to protect it if it needs to be protected, if it's confidential in some way and so on. So these things pervade the whole area, yeah.
There is another thing, let me finish and then there's another, they're all connected to our leveraging value for data in real time, in real networks, not just central bank governors, but not just national statistics, but anybody else, not only Bureau of Standards. The issue of isn't it a good idea that we should unleash the use, the smart 29 as we call them, because they are born with computing and algorithms and games and so on, so they do know what means data, and shouldn't be that the future for Kenya, for Uganda, for, yeah? By the way of the question of difference between UK and developing countries. The other day I was telling you that in Kenya, a well-known company from Silicon Valley, this, what is it called? Summer Source, yeah? Summer Source. Summer Source apparently is training African youth, in Kenya specifically, in Uganda, and is going all over else, in artificial intelligence. In fact, is training, they are claiming, in becoming data scientists. But in fact, it's not a data scientist, it's simply a slave. They are slaves, so simply looking at pixels on the screen, being told now you can click because it's the right pixel, what it is, and then move on. There are millions of people like this exploited. The slavery of that is bringing in data is quite unimaginable.
I've come across similar companies elsewhere, and some of them are sort of international because people can be working anywhere around the world. A lot of these organizations are concerned with looking at, for instance, images which need to, you need a big database of images, you need to clean them, you need to classify them so that they can provide input, training data for machine algorithms and so on. And I think, you know, they're fairly easy, crowdsourcing, they're fairly easy straightforward exercises. So you can think of it as slavery, but it's also easy and cheap, and you can do the work whenever you want. I think that's different from training people. I do think, my point about the skills gap, I do think there is a very great need to train people in the more sophisticated, proper data science skills. I also think that the less developed countries have an opportunity here to, and we've seen this in economic development in the past in other areas, an opportunity to vault over, to come in at a higher level into technologies which more developed countries are trying to develop but are being sort of slowed down by the infrastructure, the plant, if you like, that they're already existing, the legacy software systems that they've already got to cope with. So I saw this with the ONS recently, which is the National Statistical Office in the UK, which has undergone a major sort of advance in the sort of systems that they used, because they recognised that they had lots of creaking legacy systems which need to be replaced. And I think less developed countries don't have that problem, that they've got to get rid of these old systems before they can put new ones in. They can come in with the new ones. And I think we've seen that with with manufacturing plant in the past in other areas of the world.
Can I just make a point in terms of, as we sort of wind up a little, what would be the key things, based on the word leveraging, that we ought to focus on?
Yeah.
I mean, a key theme that seems to have been coming out is that we should leverage the data, and not the data and people controlling them should leverage us. That's been quite an important theme right through. The other thing I just wanted to raise, it's a huge topic and it may come up this afternoon, was the question of, you had this staggering figure actually, David, of 3.1 trillion lost in America only through poor quality data. Just open up the question, even if we can't go far with it, by poor quality, misunderstood or and categories obviously can merge. Two sort of thoughts I was thinking of offering. First one, do you have any immediate reaction to those?
If you like, take control. We have to decide what questions we want to answer, what sort of data sets we need. So I think that's very important. Yes, the second point, yes, it depends how you define poor quality data. I think this report was trying to produce a headline, so it had a very loose definition of what was poor quality data, which is what enabled it to get such a big number. But of course, it's a very difficult thing to actually stick a number on. Some years ago in the UK, about 10 years ago, one of my PhD students and I carried out a sort of meta-analysis, a review of the amount of fraud going on in the UK. And we came up with, we've identified sources which had numbers ranging from £70 billion a year to £70 billion a year, a vast range. So different definitions can give you these sorts of ranges. It depends exactly what you mean.
No, I have a comment, not a question.
I was just wondering power of data as different from liberating.
I want to take over where Robert mentioned the weather. At a meeting during Bush Jr.'s presidency, I was at meetings in Washington, and there was a marked difference between the government scientists and academia scientists about the weather. I happened to come here, and I mentioned this, and we had two scientists. One was from academia, one was from the government. And the delta was much narrower than I found out in the United States. So I think, where do politics come into these things?
They come in everywhere, I suspect. But that's a nice example. But yes, that's a question about American politics, really.
Liberating data,
yeah.
the power of data, does actually give a chance for new tribes to emerge.
Yes.
I mean, there is a lot of discussion, when I say tribes, there is a lot of discussion about identity.
Yeah.
And with Fukuyama and so on.
Yeah. Yeah.
But recently one can see it in the United States and see it almost everywhere. You see it in France, see it in Europe. There are new tribes, new groupings. And I suppose that data contributes, actually, the power of data contributes that. I mean, the Me Too movement, all sorts of movements, climate movements, whatever movement, all these are new tribes, as President Museveni is calling them. He asked me which tribe I am. He referred to my cybernetics and information background as different from any other tribe. But recently, you can see that the availability of data, useful data, in particular groupings, because of the technologies that are available and make them grouping themselves, there are new groupings, new tribes, so new politics, and therefore new power.
It would be too much to hope that data and the potential information which can be extracted from it, the way it can be used, will resolve issues of, as it were, tribes being formed. I mean, it doesn't tackle sort of basic human frailties like confirmation bias and so on, where we look for information which supports our views rather than which goes against our views. So I think it would be... Data can do amazing things, but they can't perform miracles, data technologies.
But you see, when we started so many years ago, particularly the smart partnership idea, I'm sorry, I'll stop here, but it became very evident that there was a question of trying to bring in government and private sector under one umbrella.
Yes.
And they were coming from different data perspective, and different purposes that they used, probably same data, government and private sector. But in fact, very soon, 95 or so, we said there are missing partners. And the missing partner was labor, trade unions. And then there were all sorts of others, social issues, 29ers, and you name it. There were links, smart partners, cooperative links. Actually, I don't think that for the liberating value of data for the next phase of the smart partnership, those links are valid anymore. There are new links which are shaking up.
Right.
New links, new tribes.
Okay, I don't want to, Robert Smith, I don't want to be too negative, and I don't want to want you to think that I'm totally preoccupied with a dystopian future. But I think some of these words or phrases have already been used, actually. Data slaves and data drudges, maybe. We heard recently, Mahara and I, in a lecture by Professor Michael Stonebreaker, I don't know whether you know him, that an enormous amount, something like 90% of the time of people who are nominally called data scientists is actually spent in cleaning the data so that it can be fed into the machines, basically, because the data, as received, contains all sorts of quirks and anomalies.
Yes, that's absolutely right. It's an old saying that when statisticians are analysing data, 90% of their time is spent cleaning the data before you can do the fun parts and actually fit the statistical models. Yes, and he's absolutely right. And it may even be worse now, because with the massive data sets, requires more people to look at it and sift through it and so on. So
Can anything be done about this, do you think? I mean, if it's getting worse, there's an even greater need to do something about it.
I don't know if it can be changed. I mean, it is absolutely critical that your data can be trustworthy and reliable if you're going to draw valid conclusions from it. I suppose it comes right back to the original data collection stages. One just needs to try to ensure that the data is of high quality as it's collected.
Well, that means if there's more data, there's more data drudgery.
That's why I
yeah, 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 yeah.
Yes. When you were speaking, you drew a distinction between theory-based models and database models. And it seems to me that essentially the two of them have got to work together, because in a way, the only way of establishing the integrity of data is to test it.
Yes.
So you have to have some theoretical reasons for testing it. And I'm just sort of interested. I think that's relevant to the discussion that's gone on.
That point, because I think it is an important one. Our theory-based models are based on some underlying theory, Newton's laws of motion or prospect theory or something like that. Database models are just based on observing relationships, noting that in a large data set, two variables are correlated or something like that. But to validate the database models, you don't need to necessarily relate it back to some underlying theory. What you could do is say, right, based on these observed relationships in the data, I am going to make some predictions. And then you can validate the model by seeing if those predictions come true, are accurate. Now, in some sense, this doesn't mean that your model is a good representation of reality. So you're not validating it in that sense. All it is saying is that there are apparent relationships in the data which is extracted from reality, which maintain, which hold true and which are consistent over time. So validated in a slightly different sense, I think.
You may actually be influencing.
Oh, that can happen, absolutely.
And so that's the sort of feedback that you don't particularly want.
That is one of the dangers, that you can build in this sort of feedback, and that can distort your data. A bit like my crime maps example, but I have other examples where exactly this sort of thing goes on. So it is a real danger, yeah.
I mean, the power of data for politics, because we have politicians involved with that, and we hope, well, we tend to think that the smart partnership type of politicians are different, and the fact that they value the kind of open heart. The fact that the whole leveraging value of data has been put to the Commonwealth heads of government, it means that we hope that they will be empowered, those politicians, with the pros and cons of the data for the national policies and the different type of cooperation. But within the financial inclusion, what we came about against was the fact that the issue of sharing data and all the rest of it, the impact of data, makes regulatory and legal aspects essential, much more important than politics, much more important than anything else. In fact, we had an example. In fact, we had seen then so many examples of countries where crypto predators, as we call them, they go in those countries and with or without or with a feeble legal framework still in making, there are already requirements for new legal frameworks which are innovative, which are fit for these issues of data. So again, you're probably quite right to say that it's better if you don't have a kind of a lot of legal history in your country, because you can come up with completely new legal frameworks which fit this data. I mean, Malta was a case, yeah? Uganda is probably making, allowing, without realizing what they are doing, crypto predators in, not for Uganda, for the entire Africa. One didn't realize that. Cyprus is doing the same, Mauritius the same, etc. So the importance of data is also in relation to the conventional, probably, professions that we think of. Professions like lawyers, I mean, he's a lawyer, Nick, she's a lawyer, she's also a diplomat, yeah? He's a diplomat, but I'm sure he's also a lawyer. But the impact that data will make on what they profess now and how they do it is immense. And not only, I mean, because Oliver and I were very keen on this issue.
Sorry, Mahail, I just want to add something there on the crypto predators, because obviously that's something I know quite a bit
But I
about.
provoked you because you didn't say anything about it.
Well, no, I think I was just waiting.
Can't
You
talk
were
about
saying it
data
quite well,
without
but I mean,
crypto predators.
this goes back really to what is the definition of data. And we said in the beginning it was much about knowledge or assumptions that we believe to be real. What the crypto predators are doing actually is using asymmetrical data. So what they're using is, here, look at the price of Bitcoin from this year to that year, where it went up from $14 to $17,000. And here I've got a new Bitcoin for you. It's even better than the old one. And it'll probably be even, and this is playing on people's fear as well, like and knowledge. I met a gentleman quite recently in a Nordic country who had pumped a lot of money into OneCoin. And when he told me this, I couldn't help but laugh. And it wasn't out of cruelty, it was just out of, I couldn't believe that somebody so apparently educated had done something so silly. That's the problem with this technology at the moment. There's a lot of people who know well enough what it's capable of and what it can do at the moment, and there's those that will take advantage of what people don't know.
Anybody else before we go to, we will come back into this issue of data, but specifically on the program.
I wanted to make a comment.
Yeah.
My usual sort of approach
Concluding.
on behalf of the chairman, and we would like to thank Professor David Hahn for his analysis and presentation. All the members here who have had questions or contributions, and they all helped me to raise my level of confusion from a lower level to a higher level. Thank you very much.